So we've talked about the definition of continuity and what that means in the three different portions that you have to use to kind of show that a function is continuous at a point. We can also talk about continuity on an interval. So there's two types of intervals, right? Open and closed. So f of x is continuous for all points in an open interval, right? So if it's continuous on the open interval, that means it's going to be continuous at all points inside the interval, and we're not considering the two endpoints. So that's pretty easy to talk about. Now, closed interval is a little different. So for closed intervals, you have to be continuous for all points in the interval between A and B. And then it's going to be continuous on this closed interval if we take the right-handed limit as x approaches A of the function, and that equals the function value at A, and if we take the left-handed limit as x approaches B. Now, if we think about this in terms of a number line, right, if we have A and B here, right, if we have a closed interval, right, we're just considering those portions, right, as we, like, if we're bounded inside of those portions, right, we want to talk about how we are approaching from the inside of the interval. So we are going to be approaching the lower bound of the interval from the right-hand side and the upper bound from the left-handed side. So we're going to look at a graph to kind of see what that looks like. So using this graph, we're going to list the intervals of continuity for f of x. So we're going to be using our eyes. We're not going to be using like the definition of a continuity. We're not going to have to prove it at every single point in here. That would be ridiculous. But I'm going to go ahead and get started. So, right, we can see that we have a whole discontinuity here, right? So we're going to have an open-ended circle there because f of 2 does not equal, right, some things to know, right? The f of 1, because I know how to read a graph, f of 1 does not equal the limit as x approaches 1 of f of x, right? Because the limit as x approaches 1 is approaching 2, but the limit value is 3. So we are discontinuous there. So we're going to be continuous on this open interval, right? Closed circle to open circle, right? So we are continuous on right, we have 0 to 1, and then as we go into our next portion, right, again, since we're starting at 1, we're not including the 1 there. And now as we approach 2, right, the limit as x approaches 2 from the left of f of x, right, that equals, right, we're approaching it from the left, that equals 1, and that's equal to the function value at 2, right? So because of that, we can say that it is continuous from open bracket on 1 to closed bracket on 2. And then if we go to our third little piece here, right, we're starting at 2 again, so the limit as x approaches 2 from the right-hand side now is going to equal 3, but that does not equal the function value, so we can't include that point in this interval of continuity. So we're going to say it's also from 2 to 3, and then